Hi, everybody. I am Sharon Moshavi. I'm Senior Vice President at ICFJ, the International Center for Journalists. This webinar is part of our Global Health Crisis Reporting Forum. This initiative is designed to give journalists the opportunity to learn from experts like one we're about to hear right now, and learn more about how to cover this massive, fast-changing pandemic. Many of you here today are members of the forum. We now have more than 6,000 journalists participating from around the world in 5 languages. I'm very pleased to have with us today Dr. Angela Rasmussen, PhD of Columbia University's Mailman School of Public Health in New York City. She is a virologist who studies host responses to infection. She studied SARS, MERS, Ebola, flu, dengue, and of course, COVID-19. Dr. Rasmussen joined us back in March, which seems like a lifetime ago, to help us better understand how the virus spreads. And where it's now, as we know, July, and there is no end in sight. We've seen more illness, more death, more global spread. There's a lot more that we are understanding, and there's still an incredible amount that we don't. Just a reminder, this conversation is on the record, and you're free to use quotes, video clips, audio clips. We'll be posting the recorded video in a couple of hours, and the highlight quotes will follow soon after that. So Dr. Rasmussen, thanks again very much for joining us. As I said to you earlier, I wish we weren't having this conversation now, but I guess it's good that we're having it considering everything. Well, and as I also
thanks for having me.
As I said, there is still a lot has changed since we talked back in March. And one of the big things that has come back that we know now that we didn't know is talking about how the virus spreads. Just in the last couple of days, there's been talk about that. It's airborne. Scientists pushed an open letter to WHO, which is now acknowledging it and saying that it's suspended, the virus is suspended in the air via aerosols and droplets. Can you explain what actually that all means and what the health implications are?
Yeah, so this has been very confusing, I think, for people to understand. So a lot of times when scientists are talking about airborne transmission, we're really talking about 2 different things. And those are this really small particle aerosols that you were just mentioning that can remain suspended in the air for a long period of time, and the larger respiratory droplets. And this is actually talked about as if these are 2 separate categories, but in reality, it's more like a continuum of different sized particles that you produce when you speak, when you cough, when you are singing, anytime you're really breathing or vocalizing through your mouth. And really the concern is not so much the really, really small particle aerosols that can remain suspended for hours at a time, because in general, we don't have any evidence that any large case clusters have been transmitted by that. For example, things going through like an air conditioning system or an HVAC system. I haven't anyways seen any evidence that there are case clusters that can only be explained by that type of transmission. What we're talking about is really the continuum of these larger size respiratory droplets. And so we've known this basically for the last few months, that respiratory droplets are the primary driver of transmission. And what they mean by airborne in this context is that those droplets, being that they're all different sizes, remain in the air for different periods of time. And some of them will fall to the ground very quickly unless they're propelled by a fan or an air conditioning system. Some of them, though, are much smaller, even though they're not as small as the small particle aerosols or the droplet nuclei. They can remain in the air for a little bit longer. And we are seeing cases where people are getting infected probably through inhalation of these respiratory droplets. So while you shouldn't be worried necessarily if you're in the same building as an infected person on another floor because you share an air conditioning system, you should be more worried about it if you're in an enclosed space with a lot of people who are not wearing masks, especially because those smaller, sort of middle-sized small droplets can remain in the air for a longer period of time, and you could inhale them and become infected. And so that's kind of what this discussion has been about. And one thing that's been, I think, very confusing for probably both journalists and the public is the idea that airborne has been going on. This is not new information. This debate and talking to the World Health Organization about it is really more of a matter of communication about risk than it is about some new scientific finding that all of a sudden this thing is airborne in ways that we didn't realize that it was before. So I join with several of my other colleagues who have called for a change in terminology about how we discuss these different types of droplets and different types of transmission. Because regardless of the particle size, if you're inhaling something out of the air and getting infected from it, that is really airborne transmission, but that's not always what that means when scientists are talking about it. So we really do need to make this nomenclature less confusing.
Yeah, I think that would be a good idea. I do think there is a lot of confusion. So let me ask this. I go spend an hour in the grocery store. I spend 3 hours in a mall. I go to an office where everyone's socially distanced and wearing masks. What are the implications of that, given what we know now?
So, I mean, one thing, every situation is going to be different, and there are different variables for every situation that will affect transmission risk. So wherever you are, anytime, we know that there are certain things that you can do to reduce your transmission risk, and that includes accounting for these airborne respiratory droplets of any size. One is to wear a mask, even though the mask is not protective for you, that's source control, and that prevents you from putting respiratory droplets out into the environment. So if everybody's wearing a mask in the grocery store or restaurant or a store or a mall or any type of place, then there are going to be fewer respiratory droplets in the air for you to potentially be exposed to. So that's one risk reduction measure that if everybody adopts, it can make it safer for all of us. Physically distancing is another thing. So we do know that some of these droplets probably can hang around for longer than the largest droplets. But still, that doesn't mean that those large droplets aren't a risk. And because they are larger and they're higher volume, they can potentially carry more virus in them. So you want to still make sure that you are physically distanced from others and avoid crowds, because certainly if you are around a lot of people, they're all producing respiratory droplets, that increases the risk that you might encounter some respiratory droplets that have virus in them. And the final thing is to wash your hands. So even though fomite transmission or contaminated surfaces is not thought to be the primary driver of transmission, it is important for you to maintain good hand hygiene, because that certainly can still spread the virus. And one other thing, actually, enclosed spaces. So if you think about an enclosed space, a room, like an office, for example, as like a fish tank, people are in there breathing respiratory droplets, and those droplets don't have anywhere to go. They'll build up. Just like if you drop food coloring into a fish tank, eventually the water will change color. But if you drop it into the ocean, it won't change color. It'll dissipate and become very dilute. And that's really the difference between an enclosed space and the outside. When you go outside, the sky is effectively the limit. And so any droplets you're producing are going to be dispersed much more effectively than they would be in an enclosed area. So it's still not completely safe to be outside. Like, you definitely want to avoid crowds, because if you are at a concert or a festival or something and you're surrounded by people producing respiratory droplets, you might not be moving as much. You could still be exposed to virus. But indoors is thought to be a greater transmission risk, because these aerosols these airborne particles, respiratory droplets, can stick around in the air and they don't have any place to go.
We have a question from a journalist, Ernesto Gonzalez, who asks, what is the impetus objective to have the WHO acknowledge this airborne transmission, and what changes are going to come about if they do?
So the importance of having the WHO ignore or acknowledge that that feature of the
oops.
Yeah, don't ignore it. They didn't really ignore it. It's not so much an issue of the WHO ignoring data. It's a matter of the WHO being more conservative in what they communicate to the general public. And you know, the WHO is in a difficult position because they are the international body that is supposed to be providing guidance. And they're very careful about making guidance that might turn out to be wrong. And we've already seen in this pandemic, there have been numerous reports of, you know, this drug works, that drug doesn't, this can protect against the virus, that can't. There's been a lot of misinformation flying around. And so I think that for better or for worse, the WHO's motivation has been to not say anything until they're absolutely 100% sure. However, this comes back to the issue of how we communicate this stuff, because we have known that this virus can be transmitted by respiratory droplets that are inhaled. There's pretty good epidemiological evidence that that has been the primary driver of certain case clusters. So the WHO really, again, this whole issue of airborne has been more of an issue of how this information is communicated rather than the WHO, not acknowledging something or ignoring something. They just haven't communicated this because the terms themselves are very confusing. But I think it's a positive step in the right direction because that they are willing to talk about this because, as I said earlier, I think that the way we communicate this type of information does need to change, allowing the WHO to potentially make actionable guidance faster.
When we talked back in March, though, both the WHO and CDC were not recommending masks, only for healthcare workers. That obviously has changed dramatically. What went wrong there? I mean, if you're saying that we knew back in March that this was a respiratory infection, it was spread through these droplets, then why was the mask conversation, why did that take so long to make that recommendation that everybody should wear a mask?
So I'd say that we didn't have the same body of evidence in March that we have now about inhaled droplet transmission. The other issue is that I think this was handled badly by myself as well. There still is really somewhat limited evidence base about how effective masks are. So we do know that masks can reduce droplet production, and that stands to reason that would reduce transmission if everybody adopts masks. But the studies actually supporting that are, in many cases, they're designed to address issues with healthcare workers wearing masks. There is not so much evidence about the general public wearing masks. And it's really difficult to do those kind of studies, right? Like there are so many variables about the way people behave, different public health policies that are implemented. It's really hard to single masks out as the variable that you're going to look at that reduces transmission. And certainly in China, for example, mask wearing is already widespread there, and that's where this originated. So there's conflicting evidence about masks. That said, I think that there is enough evidence, and I think it was in early March, paper came out that showed that masks actually can reduce at least droplet production, and they reduce the amount of some other viruses, not this virus, but other respiratory viruses in those droplets that do get through the mask. So taken together, it's really a precautionary thing that people should wear homemade or surgical masks. I think that the guidance from both the CDC and the WHO was intended to preserve personal protective equipment for frontline healthcare workers. And there's a difference between a cloth homemade, mask and an N95 particulate respirator. I think that it was to avoid the confusion about that, and clearly that was wrong. And now the other issue with masks, at least here in the US, is that because our federal leadership has politicized masks heavily, it has become a very contentious discussion when really it should just be changing public health guidance. And that's really how I've looked at it. I mean, I was sort of agnostic on masks early on. I felt that people could wear them if they felt more comfortable wearing them, but they shouldn't think of it as a security blanket. And there wasn't a lot of evidence to suggest that they really do that much, other than act as source control. But now, just as a matter of courtesy and to set a good example, I think there is enough evidence to suggest that masks may be protective, and therefore we should all adopt them. So I always wear a mask in a public place, at the very least, just to set a good example. But I don't relax any of my other precautions that I take against transmission. So I continue to physically distance and limit my excursions to essential errands and things like that.
There was a graphic going around, or has been on social media, showing the different percentage likelihood of getting it if you wear a mask, if the other person wears a mask, if you both wear a mask, if nobody wears a mask, and time and again you're saying, and others are saying, it doesn't really protect yourself, you're protecting others. I confess to being a bit confused by that. If I'm wearing a mask, why am I not also protecting myself as much as protecting you?
So a lot of this has to do with the size of these droplets and the fact that they are made out of water, mostly. So if you are exhaling into the mask, those droplets are getting caught very close to your face. And any virus that is on those is presumably going to like stick to the fibers of the mask that it is exposed to. If you are wearing that same mask and somebody breathes at you and their respiratory droplets get stuck to the outside of the mask, eventually the water in those droplets will start to evaporate, and that mask is not super tight. I mean, it's like the virus compared to the weave in a given mask is like, a golf ball going through a chain link fence. Eventually, if those droplets evaporate enough, that will be small enough that you could potentially exhale that in. But the reality is we don't actually know what the risk is. We can't really assign percentages. One thing we can be sure about, though, based on research that's been done, is that masks do reduce droplet dispersion into the environment. So while we don't really have much evidence to make a judgment about how protective masks are, they might be. But as I mentioned, if you are just collecting other people's droplets on your mask, there is a possibility that you could inhale droplets that are too small to be kept out by the mask and get infected that way. But the reality is we just don't actually know that much about it. So I think out of precaution, people are not saying that masks are protective. And the other thing is sometimes, and this has been shown in healthcare workers, people can engage in higher risk behavior if they think that they're wearing something that protects them universally. So it's a good idea to understand that masks, at the very least, are likely have some protective effect. They are one risk reduction measure among several that can be taken to reduce transmission in the community. But I think we don't have the evidence to make judgments and put a number to how protected you are, how protected somebody else is. We actually don't even know how much virus you need to be exposed to in order to become infected. There's still a lot of really fundamental questions we don't know about this virus, including masks. So that's why, out of precaution, again, to reduce community transmission, we recommend everybody wear masks. To protect against individual transmission, that's where, changing your behavior, physically distancing, not going to crowded bars, staying home as much as possible. Those types of controls are the things that you should really do to protect yourself.
We have a question from Dini Martini, who says, we have known for some months that COVID can stay in the air for about 3 hours. Does this new evidence say it stays longer? And if so, how long?
Okay, so that study was based on a paper that was published in which they use a nebulizer and a drum to generate laboratory generated small particle aerosols. And those are supposed to replicate the types of aerosol particles that will be generated during certain medical aerosol generating procedures, such as intubation. Or nebulizer use. There's a lot of different ventilator use. There's a lot of different types of medical procedures that can generate these aerosols. So that's really why that was done. It was also done at the time, we didn't really know much about whether this could be transmitted by small particle aerosols, such as through air conditioners, air conditioning ducts, or HVAC systems, as I mentioned before. So that's what that says. And that is going to be, that's under laboratory conditions. That's the most important part to remember. So in the real world, there are other variables, again, that come into play. So if you are in a hospital, for example, where they are generating these types of aerosols through the procedures that people are doing, often those procedures are done in negative pressure rooms to make sure that those aerosols aren't escaping. But even though we do produce small amounts of small particle droplet nuclei when we speak or sing, those are not the majority of the droplets being produced. And that's why we think that, this mode of transmission is probably not the dominant one. It's probably larger droplets because, again, we don't have any epidemiological evidence that that type of transmission has really occurred. So, I would worry less about the half-life of the virus in the air because 3 hours, again, that's indoors, probably less if you're outside. Temperature and humidity and wind will have an effect on this. I wouldn't worry too much about things like how long the virus persists in the environment. The key here is to protect yourself from being exposed to virus in whatever environment that you're in. And it's those same risk reduction principles that I've been talking about, like a broken record this whole time. Wash your hands, avoid crowds, wear a mask, physical distance, try to avoid other people in enclosed spaces in particular.
Great. We have a couple of questions about immunity and antibodies. Let me read one of them, which is, what do we now know about antibodies? There was a Spanish study that seemed to show that there was not resistance to the virus by many who contracted the disease. Does that mean that herd immunity is a non-starter?
So that's not entirely what that study shows. That study shows that there is a low rate of seroprevalence in the population, which means there's a low number of people who have antibodies. And some people have suggested that means that people who did get it don't have antibodies, which may be the case. There are studies that show that people who have very mild or asymptomatic infections didn't have detectable antibody titers a couple months after they, were recovered or ended quarantine. So it is possible that we're missing some people. Serology tests are notoriously imprecise. So the moral of that story, though, is that even if there is a small percentage of people who aren't making antibodies anymore, it doesn't mean that they're not protected. There are other forms of immunity besides antibodies. There are T cells. Also, antibodies are made by B cells, and memory B cells stick around long after you're infected. So if you're exposed again, those B cells can become activated and start making more antibody. We don't know if that's what's happening. People are obviously studying this, but that's just not having antibodies doesn't mean that you're not immune. But the real take-home message from all of that is that most people have not been infected with this virus. So the idea that we could get naturally acquired herd immunity, which is really a misuse of the concept and the term herd immunity. Herd immunity has been discussed in the context of vaccines only. We've never really reached herd immunity with endemic diseases really ever. I mean, smallpox was something that infected people all over the world for millennia, and we never reached herd immunity against smallpox. It was only when we had a vaccine that we were able to successfully achieve herd immunity globally and eradicate the virus. So it's really important to remember. I mean, the take home for me from that study is not only are most people probably susceptible, but I hope that this cans all discussions of let's go for natural herd immunity, because I think it's a terrible idea. Even with a low case fatality rate, that means millions of people worldwide will die from this virus. In Sweden, where they've sort of attempted this, it hasn't even really provided much of an economic benefit either. So I think people really need to consider what they're asking people to do when they're saying, oh, we can get herd immunity by just letting everybody get infected. And that's, to me, the most important finding from that Spanish study. It's also consistent with serology studies that have been done in other parts of the world, including in the US.
That's really, really helpful. Thank you. We have a question here from Edna Basurto about, is COVID-19 transmitted via pet animal exterior body to another human when it has been exposed to an infected human? And I guess the question there too is about surfaces, right? I remember back in March, everybody was wiping everything down, terrified to touch anything. I think this goes to that. What have we learned now about infection spread through surfaces?
So it does seem that there are fewer cases based at least on epidemiological evidence that fomite transmission is a major driver, although I don't think anybody's ruled it out. I don't think anybody thinks that it doesn't happen. I think it's more likely that it's just not the dominant form of transmission, which does appear to be these respiratory droplets. I think that means you should still consider disinfecting high-touch surfaces, and why I tell people to continue practicing good hand hygiene, because that's really one of the keys to reducing fomite transmission. With regard to pets, I'm not sure if the question was also about pets. We do know a little bit more about that, and I think it's really unlikely that you would, I guess if you have a cat or a dog who licks themselves all the time and then you pet them, just wash your hands like after you're petting your pets. We do know, though, that cats and dogs are capable of getting this virus. They're capable of getting the virus transmitted anthropogenotically, which means that they're getting it from humans. We don't really know how easy it is for them to give it back to us zoonotically. So I think that it's worthwhile that if you are continuing quarantine practice, to continue that with practice with your pets, especially with outdoor cats, because cats do appear to be fairly susceptible to this virus.
We have a question here about how can the virus affect the brain? And I just want to add on to that and maybe have you discuss what kind of infection is this, right? I've seen a recent study, 40% of COVID-19 deaths are related to vascular issues, blood clots and things like that, as opposed to respiratory issues. Can you talk a little bit about how it's affecting the brain, other organs of the body, and what this means?
I can, but not much. Right now, this is a really huge area of interest to me, because this is more or less what I study, is the host response to the virus. It's very interesting. Like, we don't understand, first of all, this virus produces a really extreme range of symptoms in people who get it. So some people have completely asymptomatic infection, or at least very, very mild infection. And some people die of all these really diverse syndromic diseases. So it's that in itself is a mystery, but we don't know a lot of things about this virus in terms of its tissue tropism. So we don't entirely know all the different types of tissues and cells in the body that it infects. We don't know if these vascular abnormalities that are being seen, or the coagulopathy, or issues with blood clotting, are the result of a direct infection of a particular cell type, or if they are the result of indirect effects from systemic inflammation. And the same is true for the brain. So just today, Reuters was reporting that a number of people have reported these neurological sequelae occurring after they've recovered from COVID. And we've heard about these so-called long haulers who have symptoms for months, including some neurological symptoms. And right now, we really don't know much about any of what causes that. It could be just the lasting effects of injuries that were done when the patient was very sick. So we do know that, you can certainly get lung injury. COVID-19, severe COVID-19 has been associated with what we call a cytokine storm, which is sort of out of control inflammatory state that your body is in. And we don't know what kind of long-term effects these have. They can have a lot of different things. There can actually be immune damage to the tissue itself. You can have scar tissue form in places where it shouldn't, like the lungs, for example. That can decrease lung capacity. You can have liver injuries and kidney injuries that don't get better even after the virus is gone. So it makes sense to me that we're also seeing neurological injury. And there are other, for example, with the Ebola epidemic of 2014, a number of those survivors had infected so many people that we were finally able to see some of the more rare secondary effects of the infection. And people who'd long since recovered from Ebola have reported neurological problems, ocular problems. So this is not something unique that this virus necessarily does, but we don't know exactly how this virus does that.
Well, again, lots we still don't know, as it's becoming obviously increasingly clear. A question here, which we talked about a bit before, is communication, from Jaya Sridhar. How do we communicate as journalists the uncertainties in the evidence and the consequent changing public health guidance in our stories without confusing the public?
That's a really tough one. I mean, scientists haven't always done a great job of this either. We haven't always communicated clearly to journalists, and this Airborne story is a great example of a time when the terminology can be confusing even to scientists. I would say that, if you are covering something that's outside of your subject matter area, your comfort zone, you're using terminology that, is unfamiliar to you, or you're less familiar with how to read a scientific paper critically, talk to experts, like talk to scientists. And when good scientists, we have a problem with this too. There are people who are so excited to talk to journalists or to see themselves on TV that they will talk about any topic, regardless of whether or not they're qualified to do so. So first, reach out to experts. And if those experts say, I don't know, which is what I say if somebody asks me a question about, oh, what is the difference between the Imperial College model and the UW IHME model? I have no idea. I'm not a modeler. I'm not an epidemiologist. So in those cases, I will refer journalists to experts who can speak on that and are qualified to do so. So I just think, I understand the pressures of trying to get out a story. I've had journalists contact me and I've said, I'm not qualified to discuss this. And they're like, well, can you just give me your opinion anyways? Because, I'm on a deadline. And I sympathize with that, but I can't give my opinion on something I don't know anything about, because we've seen how this type of misinformation can be extremely harmful. So I'd say just, if your editor's bugging you to get something out, don't get something out. Like, if it's not complete, if you aren't sure that you're publishing something that communicates the story in a correct way, I'd say push back and try to just seek out experts and ask people if, they say, oh, I'm not qualified to talk about this. Ask them if they can recommend somebody who is. So that way you're talking to independent experts who are not involved with the study or the even press release that you're reporting on. So you have some independent expert perspective on that. And I think that really goes a long way to help put it into context for the general public, because most of these things are not categorical. They're continuous issues that require a lot of context to understand. So it's really important. I mean, it's helpful for me too to understand things that are outside of my subject matter expertise by even just seeking out, epidemiologists on Twitter or health economists or anthropologists or people who are, in really different fields than me, who can help me understand a complex issue.
That is very, very good advice that I hope people will follow. We have a question from a journalist in Nigeria who says, there are claims that some natural immune boosters like garlic and ginger can help those who have contracted the virus. How true? And I will add on to that. There's also been studies about vitamin D, for example, that it helps you prevent contraction, but helpful if you do get COVID. So can you talk a little bit about sort of these sort of quote unquote natural immune boosters?
Yeah, so there's a couple things here. First of all, boosting your immune system isn't really a thing. Your immune system boosts itself when you are exposed to a pathogen. The other thing is you don't actually want to boost your immune system, because that's how you end up with autoimmune disease. Your immune system is designed to work very specifically against pathogens. And so boosting it, first of all, isn't really something that you can do. And second of all, actually the cytokine storm that causes COVID is an example of what happens when the immune system gets boosted during a viral infection. It can be very harmful. And second of all, I don't see anything wrong with looking into whether any kind of alternative therapy actually works. If there's anecdotal evidence to support it and it's not harmful to people, I don't see the harm in doing, a clinical trial to see if it does. But if something is not proven with a clinical trial, I'm not inclined to have that be my first line of defense. I mean, it might be, comforting to eat chicken soup with a lot of garlic in it. If you're sick, it might be good to drink tea with ginger in it. But I wouldn't go into that thinking that it has any sort of medical benefit or that it should be used instead of a drug that actually is proven to work. So we don't have very many drugs that are really proven to work, and their efficacy is really incremental at this point. So, at this point, I would say that if you're not like deathly ill, if you're just sick at home and you want to make yourself some tea, go ahead and throw some ginger into that. But don't talk to your loved one who's on a ventilator's doctor and tell them to put them on ginger or vitamin D instead of remdesivir. I think that, it's fine to use home remedies if it makes you feel better. There's something to be said about the benefit of the placebo effect at the very least. And certainly, some of these things are definitely worth looking into. But there's no evidence right now that any type of natural remedy can have any sort of measurable clinical effect on treating COVID-19. So I hope that doctors will not be prescribing that. But if people do want to do that at home, and they're not severely ill, I don't see much harm in doing that, as long as they understand that it's not a cure.
That's helpful. We've got a lot of questions. I'm going to try to get through as many as I can. Here's one about vaccines. How important do you believe incorporating a T-cell response and not just antibodies will be in effectiveness of a potential vaccine?
That's a great question, and my answer is I don't really know. Certainly, T cells are critical in long-term immunity. So there's two types of T cells. One, the CD8 T cell goes out and kills. These are the so-called killer T cells. It goes out and kills infected cells. The other type, the CD4 helper T cell, actually coordinates immune responses for both B cells that make antibodies and the CD8 killer T cells. So it is, I think, probably for long-term immunity, really important to have a robust CD4 T cell response, because you really need that to coordinate an effective immune response. You also need that to develop the type of long-term immunological memory that a vaccine is supposed to induce. Is it as important to have the CD8 killer T cell responses? I don't know. Several studies have suggested that there may be some T cell cross-reactivity, and T cells might be important in immune responses to this virus. I mean, T cells are generally an important part of your immune system, so they're probably important. But if the question is really, is it good enough to just have a vaccine that we can measure in terms of antibody titer? Again, we don't know. And it partly depends on how that vaccine, what that vaccine is expected to do. So there was kind of a little bit of some drama about the Oxford adenovirus vectored vaccine and a study that was done in rhesus macaques that were then challenged with COVID, or with SARS coronavirus 2. And the animals were protected against pathology. So they, their lungs were clear and they didn't develop any respiratory disease, but they still had virus replicating and shedding in their upper respiratory tracts. So that didn't provide sterilizing immunity, although it did protect them against disease. And my opinion is that really, who cares if you still are infected if everybody has access to the vaccine? Because what we really want is for people to not get sick from this virus. So, I think that we are going to probably be taking the first vaccine that's safe and sort of effective. And maybe we will be able to develop more effective vaccines later. And as we do all of that work, we're going to find out a lot more about how the B cell and T cell responses both contribute to long-term protective immunity. So this is a question that I can't really answer right now, just because we don't have enough information. But I'd say probably T cell responses are important to some degree. It just really kind of depends on which T cell responses and in what context.
This leads into the next question that I see here from someone. Do you see any hopeful therapeutics on the horizon, right? Because obviously good therapies are going to make a big difference and could potentially come before a vaccine.
I mean, the therapies that are on the market right now are a good start. Remdesivir doesn't work very well when given to severe patients to affect mortality rate, but it does reduce people's time in the hospital. And when you think about it in purely economic terms, that's a huge cost savings. If those people are being released earlier, discharged earlier because they're getting better faster, then that could have long-term impacts on their own diseases and their recovery process. So it's great that we have something, even if it's not a miracle cure. I think that there's promise in treating patients with remdesivir earlier in the course of their disease before they get very, very sick, because most of the clinical trials so far have focused on patients who are already hospitalized and very, very ill. It's a great finding that dexamethasone may have a benefit to treating patients who already have really severe disease, not in terms of treating their viral infection, but in terms of treating the symptoms that they have as a result of severe COVID-19. So we do have a couple tools already. I think that if there were a therapeutic that could either be an antiviral that was easy to give early on, had prophylactic efficacy, or a drug that would really effectively reverse severe disease, all of those things, any of those things would be a game changer. So I think that continuing to develop therapeutics, and especially continuing to develop broad spectrum therapeutics that could be used to not only treat this virus, but other viruses that might emerge in the future, are going to be really critical for pandemic preparedness overall, and could potentially have a major impact, positive impact, on ending this pandemic.
What about, we have a question here about mortality rates. What do we know for a fact now about mortality rates?
So this is really a question more for an epidemiologist, because there are multiple types of mortality rates. There's the infection fatality rate and there's the case fatality rate. And these can be different for every community. They can be affected by a whole bunch of different variables, access to healthcare, healthcare capacity, healthcare infrastructure, general health of the population, health status, existing comorbidities in the community, cultural behaviors, all sorts of different things. So it's really hard for me to answer this question other than ask an epidemiologist. And for the
following your own advice. Following
my own advice. I try not to answer questions that I can't answer. In general, the studies that I've seen have reported an IFR anywhere from 0.3% to like 3%. And again, it's going to vary in every community, but I'm not really the one to speak to what the variables are driving those estimates. I mean, in my overall worldwide, like the average case fatality rate, to put it in perspective, like the 1918 pandemic had a case fatality rate globally of like 1% to 2%. And that seems like really low, but again, in a pandemic, that equates to millions of people. So even if it's low, I myself don't pay as much attention to the mortality rates, because it's already high enough. We already have here in the US hospitals being overwhelmed in Texas and Florida and Arizona. It's clearly like a problem, more than the seasonal flu or other viruses that we normally deal with. So I don't pay so much attention to what the actual number is. I focus more on the things that I know about to try to contribute.
We've got a question here from Bonnet de Bod, a documentary filmmaker in Johannesburg, who asks, if I'm wearing a mask but no eye protection, surely the aerosol particles will still enter my body through my eyes? Should we also be wearing some sort of eye protection to prevent community spread?
So that's a great question. And the answer is, I don't know, because certainly the eyes are a potential route of infection. But I will say that eyes, the dose that you need to be exposed to in your eyes may be different than the dose you need to be exposed to in your nose. Or it may be a different kind of disease that is caused through conjunctival or ocular infection. I know several infection preventionists who have been pretty staunch advocates for wearing face shields as well as masks or instead of masks, saying that face shields may be actually more important than wearing masks, because face shields also provide a barrier against droplets, although they're not, I guess ideally, and what people in hospitals do is they will wear a mask with a face shield. But ideally, you're talking, and hopefully, as long as you're not moving your head around, your face shield's not on in a wacky way, a lot of the respiratory droplets that are coming out of your mouth are going to go hit that face shield. And they also provide a physical barrier to you, although things could still get in the sides or from underneath. But a face shield or laboratory goggles would actually provide that kind of eye protection. So again, depending on your comfort level, you could certainly wear a face shield in addition to a mask or instead of a mask, but there's really not a lot known. It's really hard to give risk estimates about either ocular infection or face shields versus masks.
We have a question here from Peru that said, there are some reports of COVID detection in Europe in November or December of last year. Based on past pandemics like the 1918-20 flu, how long before the first cluster was detected in China is the virus likely to have really emerged? Given the international movement of people, how early might it have been present in Europe or even the US?
So that's a great question. And my answer for that is, I don't know. I think that one of the really big open questions about this, which Virologists kind of debated back and forth how important this is now, but I think it's very important. Is how this virus did get into the human population, because this virus, the first case, as reported, I believe, in the Lancet in February, the first known case of this was in early December in China. And that's how we know also that this probably wasn't associated with the seafood market in Wuhan, because that first patient had never been there. So how did they get it? You know, did they get it from an animal? Did they get it from another human being? We don't know right now. And there's very little that we do know about how this virus managed to enter the human population. But what is quite clear is that this virus is very well adapted to transmitting efficiently between human beings, which to me anyways suggests that it may have had a period where it was circulating in people and either not causing much disease, it wasn't noticed, in order for it to adapt to become such an effective human pathogen. And we do know also that many people who get this disease have either very mild or asymptomatic infection. And I mean, think about how many times you've probably gotten a cold. How many times did you go get a lab test to diagnose exactly what virus was causing that cold? So it's possible that this virus could have been circulating in people before that, but we just don't know. So I'm not convinced with the evidence that has been presented about cases much, much earlier in Europe. I mean, I've seen people now suggesting that there were cases in spring of 2019 in Europe. And I have not seen anything conclusive to support that, other than just we found a PCR positive sample from a patient from that time period. That's not the scientific standard to, this extraordinary claims require extraordinary evidence, and that's not extraordinary evidence. That could be a false positive. So right now the jury's still out. I think it's really important though to do that type of work, to go back to historical samples and screen them so that we can understand a lot more about this virus's origins, because that will first of all help us to understand how this pandemic got started. It also will provide us information that will be helpful in preventing another emerging coronavirus pandemic.
Here's a question that I think a lot of people are interested as well, as mutation. This is from Sophia Toma Cruz. Has the virus mutated? And if so, what does this mean for how countries should respond in the coming months?
So yes, the virus has mutated because it's an RNA virus, and RNA viruses do mutate. And yes, some mutations have emerged, including the famous now D614G mutation in the spike protein, which it changes an aspartic acid residue at one point in the spike protein to a glycine residue or amino acid. And there has been a lot of press attention to this particular mutation because the authors of the study who described this have associated it with an increased transmissibility. However, we have no evidence to suggest that mutation actually does that in people. They've done some experiments using sort of surrogate virus systems in which they've shown that it has increased infectivity, meaning it can make more virus and that virus can infect cells more easily. But that's actually much different than showing that happens in the real world. Right now, there's just a correlation with that mutation being prevalent in the US and Europe. And that could be driven by several things. One, it could be what we call a founder effect, meaning that the first viruses that ended up in Europe were the first ones there. And so that's why they're more frequent than the original D614 strain that emerged in China. And that strain in turn was imported to the US, and that was imported more frequently, so it became dominant there as well. We've also have not sampled as much around the world in terms of virus sequence data as we have in North America and Europe. So it could be just an issue of sampling bias as well. But right now, we don't have any evidence that suggests that mutation has a functional effect on anything having to do with human disease. So it doesn't necessarily make the virus more pathogenic. It doesn't necessarily make it more transmissible. That said, the evidence is compelling that there may be positive selection on this. This mutation may have a function and have functional importance. So for that reason, we should continue studying it and try to unravel whether it is actually playing a functional role or not. But in terms of mutations that would allow the virus to evade a vaccine, I know a lot of people have expressed concern about that as well. There's no evidence that spike protein on this coronavirus is mutating to the point where it would be immunologically distinct. So for right now, I mean, mutation is just viruses doing what viruses do. It's not anything to be alarmed about. It's perfectly normal, and we don't have any indications that it's making this virus worse.
Let's talk about kids for a second. There's a question here from a virologist / educator, points out that the American Academy of Pediatrics here in the US issued a highly cited set of guidelines to reopen schools that seems to question the potential for transmission from among children, reduced susceptibility among children, downplays concerns for asymptomatic child transition, etc. What are your thoughts about that? Are children less susceptible? Are they less likely to spread? Is this all a fallacy?
So we don't know. The evidence is somewhat conflicting. Some studies have found that children don't transmit as easily. Others have found that they do. A recent study this past week showed that children did have infectious virus in their respiratory passages. Previous studies have showed that among German children, they had the same distribution of viral loads as adults, who were including adults in the highest risk group, the 80+ adults. So children can definitely get infected. We don't really know, though. The evidence isn't quite clear on whether they are more likely or less likely to transmit the virus to somebody in their household. It may be that, children are in general less susceptible to it themselves, and therefore they're not making as much virus, and therefore it's harder for them to transmit. It could be some other thing that makes it just that they're not shedding as much virus. We just really don't know. So that's that question. That's a big open question, and it's really important. With regards to the American Academy of Pediatrics recommendations, that's an example of me getting outside my lane. So I'm not going to comment other than to say that it is clear, I think, to everybody, whether you have a medical or scientific background or not, that, this long-term sort of quarantine pandemic world that we live in is having a profound psychological effect on many people. And I think that probably is part of the motivation for making those recommendations. So I wouldn't say that those are strictly based on like the virology or epidemiology science of it. I think some of those recommendations are probably based on the fact that there are other things to consider in terms of children's health and development. And so that's kind of how I've been looking at it, because I don't really, know what to think. As much as I think that, school, I wish everything could open back up. I've really been struggling with how safe it is to open schools, not just for the children, but for the staff, and for the people in their families. And it's really, there are so many unknowns. It's going to be a really tricky thing to balance the needs of those kids that are not virology related with the needs of the rest of society based on an incomplete set of evidence.
There's a number of questions here about the origin of the virus. China, it's one of the questions here says that China is supposed to be starting to investigate that. How important is finding out the origins, and are we too late into this to really be able to figure out where this came from?
I don't think we're too late, but I would point out that we're still learning about the origins of SARS Classic 20 years later. So it's not going to be necessarily something that's going to be easy to figure out. I think it is a really important question to figure out, first of all, what bat species this came from, if there were any other types of intermediate species involved in its spillover. Those are really important questions just for understanding the biology of emerging coronaviruses. And even if it doesn't help us contain this pandemic, it will help us contain pandemics in the future. We'll have more information on how to prevent something like this from happening again. I think it's also important from a foreign policy perspective, at least here in the US, because we've been beset by these conspiracy theories about laboratory origin suggestions that this virus was either engineered or accidentally released. In my opinion, those are far less likely than a natural emergence event, although I can't rule them out completely. So I think it is really important to do this investigation. And I believe that China is allowing WHO to participate in this investigation. So that will be helpful. I think that just for the public dialogue about this, I think it will be very helpful to rule out lab origin if that can be done. Just because I think that it has been incredibly harmful to discussions on this. And at least one group, the EcoHealth Alliance, that was doing really, really crucial bat surveillance work, had a grant taken away at President Trump's request because of the political issues surrounding this question. So I think, I'm very hopeful that we'll get some kind of information sooner rather than later on whatever the origin was, so that we can start focusing on the things that will help us be better prepared for the next pandemic, rather than focusing on all of these really harmful political narratives about it.
We have a couple of questions here, and again, too many questions. I think we're not going to be able to get through all of them. We've got 47 more, but I'll try to combine a few. We've got a few questions here about terminology. Disha Shetty from India is saying the government there has yet to acknowledge community transition. How does the terminology used affect response? A question also from Ida Juiced, who says, since a change in terminology could be expected once the WHO has studied airborne transmission, what would be your advice re how it should be worded and framed? So do these terminologies like community transition matter, and how should we be framing things going forward?
So community transmission, I didn't realize that about India, first of all, that they're refusing to use that term, which is somewhat troubling, because community transmission, I think, is a pretty easy term for everybody to understand. That's essentially when you have transmission going on in the community that's, that you can't trace it. There's so much transmission in the community that you can't say, if you get coronavirus, you can't say where you got it. You just got it from somebody in the community because it's so rampant. With regard to the airborne thing, that's a tough question. And I'm not sure that I can answer that. And I'm not sure that, in fact, I don't really have any preference or suggestions right now. I think this is something that needs to be done by a multidisciplinary group of people, to make sure, including stakeholders from the public, to make sure that whatever terminology is agreed upon is something that everybody can use consistently, feel okay about, and understand. And so I think that, I bet if you asked a bunch of different scientists what the terminology should be, I bet you'll get a bunch of different answers from every single one of them. This is something that really needs to be done as a group, to make sure that we are not getting back into these same problems of, debating airborne aerosols versus non-airborne inhaled respiratory droplets when they're both airborne. And that's what the term airborne means. And that's what everybody understands it to mean in the general public when scientists think it means something else. So I think that it's really important that whatever terminology we use, it's something that is really standardized and something that everybody can access and understand the context of.
Here's a question from Sergio Spagnolo in Brazil about models. He says there are a lot of people using epidemiological data to make analysis and forecasts, but epidemics seem to be very susceptible to several different variables at once, and a lot of them get stuff wrong. How to better communicate that data so we know how to be more clear as journalists and honest with data limitations and knowledge? Because you do, right? You see these models, they're all over the place. Journalists cover them. What are we to do?
Yeah, that's a great question, and one that I'm not sure that I'm qualified to answer because, I know the basics of what models are, but I don't do any type of work like that myself, so I can't really speak to some of the particulars about how scientists should be communicating that work to journalists, much less how those journalists should be communicating it to the public. I mean, the one thing I always try to tell people is that, because this has been something that on social media I've heard a lot of, you guys were wrong, the models were wrong, and most models are going to be wrong. Models are only as good as the data that you can put into them, and the data that we had in February was pretty incomplete. We know a lot more about this virus now, so the models, are continually adjusted based on new evidence, and that's the way that science in general is supposed to work. It's changing. So I think the best way maybe to communicate it, at least as far as I'm qualified to say, is just to provide more context to the public about the uncertainty of these models. They're not a crystal ball. They're not a promise of something to come. They are a best guess, basically, on the information that we have at the time that they are made, and they're going to be constantly adjusted. So they're useful in terms of trying to know basically let's brace for the worst. But they're not going to necessarily be 100% accurate. And we have to understand that and adjust our expectations for what they're telling us. It's one piece of information, but it's not the end all be all. And I feel like with many things during this pandemic, the modeling thing too is something that's been looked at as a really black or white issue. So it's either right or it's wrong. But the reality is somewhere in the middle. It's more complex. And I think that one thing in general I'd ask all journalists to do, and I try to do this myself too, is to just provide people with context, to don't present things in a dichotomous way as, a choice between one of two options. There are usually many options. Things are really complicated, and they're even more complicated when there's a bunch of stuff that we don't know, which is still the case for this. So I just encourage everybody to try as hard as it is to include as much nuance and context as you can when reporting about some of this stuff, including the many uncertainties.
Yeah, I think if I could count how many times you had to say, I don't know, or we don't know, I mean, that it's a lot. As you say, there are still a lot of uncertainties.
And it's on scientists too. Scientists need to be able to say, I don't know. People should not be answering questions that are way outside of their subject matter expertise.
So I'm going to throw one last question at you from somebody. We'll see if it's in your area of expertise or not. It's about blood types. And it says, in researching SARS in the 2000 outbreak, there has been a 2005 study linking that virus to blood types. Seeing as SARS-CoV-2 is similar, and we have seen reports about this, can we expect something else here? Is COVID worse in certain blood types?
So we have seen some information that suggests that there might be a correlation with disease severity and blood type, but that's another. I'll just conclude with I don't know. Certainly, it's possible. I mean, it's something to look into. And anytime we see interesting, I mean, this is a great example of trying to put things in context, right? So a big correlation came out between blood type and coronavirus outcome. So does that mean that, if you're whatever blood type, that you're not going to get infected or that you're not going to have severe disease? No, that's not what that means at all. It means there's a correlation. There are all kinds of correlations in the world, and anybody who's read Freakonomics can tell you that there's all sorts of spurious correlations in the world. It doesn't mean that we shouldn't look into that. We absolutely should. If there's any indication that something like that might be a predictor of clinical outcome, we absolutely need to study it. But we shouldn't be reporting blood type. Blood type determines your coronavirus outcome, because that's A, not what those correlations show, and B, we don't know that. Like we don't know what even the basis for that, the scientific basis for that would be. People speculate about it. That's what we call making hypotheses in science, but then you have to test those hypotheses. So reporting, and a lot of people were reporting new study finds that blood type is important for coronavirus, but not really. A new study found a correlation. Somebody made a hypothesis about it, and they reported it as if that's what the study found. That's an example of, not how to report on work in progress. The real story is that people are now looking into that more closely, as they should, and they're testing that hypothesis to see if blood type plays a role, but it's certainly not conclusively known.
That's great. Thank you very much. Well, we'll leave it there. I will just simply say, I guess I have a feeling we'll probably be talking again in another, by the end of the year. This won't be over, but any thoughts about where the world will be at the close of 2020, or is that just completely, is that a big giant, I don't know?
That's a big giant, I don't know. I hope that we are in better shape than we were before. Here in the US, we might have a different president. That will change things tremendously for actually everywhere around the world, given the US's sometimes outsized influence. I think that, you know, there's still a lot of 2020 to come, unfortunately. And I'm kind of afraid to think of what, you know, our next meeting might be like, but I hope that it's, oh, remember that terrible pandemic? That was awful.
That would be wonderful.
Yeah, but you know, I'm expecting the worst and hoping for the best.
Great. Well, on that note, thank you very much for your time. Thank you, everybody who joined in. Thanks for your questions. Just wanted to give you an update on what's coming next. On Tuesday next week, we will be talking about the journalism business model. Now what? What do we do to get it going? We're going to be moderated by Vince Cerf, one of the fathers of the internet, a digital pioneer who has taken a great interest in the future of journalism. We'll have also Richard Gingras from Google News, Nishant Lalwani from Luminate, which is owned by the Omidyar Network, and Patricia Torres-Bird from the Media Development Investment Fund. So I urge all of you to join in then. That will be 11 a.m. Eastern time in the US on Tuesday next week on the 14th. Dr. Rasmussen, again, thank you very much for joining us. Very much appreciated, and get some rest.
Thank you, Sharon. Thanks for having me. Take care.
Thanks. Bye-bye.
Bye-bye.